Welcome to Extreme Physics,
a crash course in physics by Rachel and Erin.
Episode 5, Speed versus Velocity and Velocity versus Acceleration.
In this video, Erin's extreme NASCAR abilities will help us understand the differences between speed, velocity, and acceleration. In our previous videos, we discussed speed to a great length. You should all be experts now, but just to review,
speed can be calculated as the distance, which is measured in meters, over the time, which is measured in seconds.
Velocity is related to speed, but it's a vector quantity. Remember those?
Vector quantities are measurements that include both a magnitude and a direction.
Erin is going 120 meters per second, which you can see in the speedometer shown in the middle of the track. Speedometers cannot determine Erin's velocity, though, because her direction is not shown. This is why they are called velosometers. Velocity is a measure of both speed and direction. When determining velocity, both of these parts need to be known, because it's defined by both an object's speed and the direction of an object's motion. Change in velocity can occur when either the speed or the direction changes. Let's look at Erin as she starts her race. As she leaves the garage, Erin begins to speed up. As you probably know, this is called accelerating. But what does that really mean?
Acceleration is a rate at which velocity changes. A rate is always a value over time, which is why acceleration equals a change in velocity over change in time, which is equal to the meters per second, which means that acceleration's units will be meters per second squared.
Just like velocity, acceleration is a vector quantity. Because velocity is part of acceleration's definition, when there are changes in velocity, it affects acceleration. Just like velocity, acceleration is a vector quantity. Because velocity is part of acceleration's definition, when there are changes in velocity, it affects acceleration. This means that if either the speed or the direction components of velocity change, there is a change in acceleration. You can see this in Erin's race. When she speeds up to get her maximum speed, as well as when she slows down to finish, she's accelerating. However, because direction also affects velocity, and therefore acceleration, when Erin turns the corner of the track from the straight part, she's also accelerating. If Erin wanted to have constant acceleration, she would have to travel in a straight line at an unchanging speed. However, I don't think this will happen today here at Extreme NASCAR competition.